Okay, so welcome. In my previous video, I introduced us to valid and invalid arguments and how you can use symbols and truth tables to determine for sure whether or not a particular logical argument is valid. And then I promised you that you don't always have to go back and construct a whole truth table if you recognize the form of a logical argument as one that you already know represents either a valid argument form or an invalid argument form. So in this video, I'm going to show you some of the basic kinds of argument forms to look out for. The maybe simplest form of an argument is where you say, if P then Q, P, therefore Q. That is, you're saying, if one thing is true, then another thing must be true. And that first thing is in fact true, therefore you can conclude that that other thing must also be true. And if you want to use the fancy Latin term for this kind of argument, it's called modus ponens, or you can also just call it direct reasoning. So an example of this kind of argument would be, if something is a bird, then it lays eggs. Blue jays are birds, therefore blue jays lay eggs. So here P stands for being a bird and Q stands for laying eggs. Next kind of argument, if P then Q, not Q, therefore not P. So this is a valid argument. It's called, again, it has a fancy Latin term, modus tollens, but you can also call it indirect reasoning or reasoning by contrapositive. And if you watched the last video, you've already seen one example of this kind of argument. If Maynard is the person who broke into Mrs. Higgins's house, then Maynard wears size 8 shoes. Maynard does not wear size 8 shoes. Therefore, Maynard is not the person who broke into Mrs. Higgins's house. If P were true, then Q would have to be true, but Q is not true. Therefore, P must not be true, because if it were true, then Q would have to be true as well. And this is called reasoning by contrapositive, because if you remember in the previous video where I talked about what the contrapositive of a conditional statement is, if you have a conditional statement, if P then Q, the contrapositive of that would be if not Q, then not P, and that is logically equivalent to the original conditional statement. So if you know that P implies Q, you automatically also know that not Q implies not P. So this is a valid argument because the contrapositive of a conditional statement is true whenever that conditional statement is true. Here's another kind of valid argument, what we call a disjunctive syllogism, because it relies on a disjunction, an or statement, as its first premise. So it says P or Q, not P, therefore Q. So basically you're saying that one or the other of two things must be true, and then you rule out one of them, so the other one has to be true. An example of this would be, either it will rain on Friday or it will snow on Saturday. It did not rain on Friday, therefore it will snow on Saturday. And that is a valid argument. Another kind of valid argument that shows up often is reasoning by transitivity. So the first premise says, if P, then Q. The second premise says, if Q, then R. And so the conclusion is, if P, then R. So anytime P is true, Q must be true. And then, since Q is true, R also has to be true. So starting with P, you logically have to get to R. An example of this kind of argument would be, if you eat beans, then you will get gas. If you get gas, then your date will go badly. Therefore, if you eat beans, your date will go badly. That is a valid argument. Here the P would be you eat beans, the Q would be you get gas, and the R would be your date will go badly. P implies Q, Q implies R, therefore, by transitivity, P implies R. Now let's look at a couple of invalid arguments or fallacies. And a fallacy is just an invalid argument. An argument where the conclusion does not logically follow from the premises. You don't have enough justification to believe the conclusion is true just because you know the premises are true. So the fallacy of the converse is where your premises say, if P then Q, Q, and then your conclusion is P. And if you watch the previous video, you've seen an example of this. If Lyle is the person who broke into Mrs. Higgins' house, then Lyle wears size 8 shoes. Lyle wears size 8 shoes. Therefore, Lyle is the person who broke into Mrs. Higgins' house. We saw in that last video, this is not a valid argument. It's a fallacy, an invalid argument. It's called the fallacy of the converse because, remember, the converse of a conditional statement is where you interchange the if and the then, the antecedent and the consequent. But just because P implies Q does not mean that Q implies P. Just because if P is true, then Q must be true, does not mean that if Q is true, then P must be true. Just because if Lyle is the person who broke into Mrs. Higgins' house, then Lyle wears size 8 shoes, it does not mean that if Lyle wears size 8 shoes, then Lyle is the person who broke into Mrs. Higgins' house. So the fallacy of the converse is kind of based on the logical mistake of confusing the converse with the original conditional statement. And then here is the fallacy of the inverse. If P then Q, not P, therefore not Q. An example of this would be, if the bus is on time, then you will miss it. The bus is not on time. Therefore, you will not miss it. So it is possible for both of those premises to be true, but for the conclusion to be false. Like maybe the bus is supposed to get there at 8 o'clock. But the bus is not on time. It doesn't get to the bus stop at 8 o'clock. Instead, it gets there at 8:05. But you're running even later than that. You don't get to the bus stop until 8:10. So you do miss the bus. The premises are true, but the conclusion is false. And this is called the fallacy of the inverse, because remember, the inverse of a conditional statement is not P implies not Q. And the inverse is not logically equivalent to the original statement. Just because the original is true does not mean the inverse is true. So just because when P is true, then Q must be true, you cannot conclude that when P is false, Q must be false. That's a fallacy. Now I'm going to follow this up with a separate video where we look at some more examples just to practice and see if you can recognize these argument forms when you see them. So that's not here. That's in the next video I'm going to put up. So stay tuned, come back for that, and see if you can practice and see if you've got the hang of these logical arguments.